I'm Lauren, but say I'm Juliet. And I have a lot of suitors, so I have a bucket on S3 with a picture of each of my potential partners and some metadata about them. And say I want to find Romeo in this bucket. On S3, all I could do is go get Romeo if I knew his name, but maybe I didn't remember his name. I can list all of my many suitors and get like list name after name after name, but that I'll max 1,000 at a time, and it's just not an efficient way to see who are my suitors that are my moody ones that want to deliver long monologues, or recent. So, how are you advancing? So on AWS S3, there's no way for me to find Romeo. Luckily, on Zenko, there will be. So we support the standard retrieval. You can go get Romeo by name. You can list all the suitors. But you also then can search on the metadata. So you can actually do SQL-like queries where you say, I want to get all the keys where the last modified date is less than some time. Or I want to get all the keys where I've said the demeanor equals moody. So the way the metadata is created is when you put an object on S3, you can say, I want this metadata with XAMZ meta headers. You can also add tags. And so we'll be searching through that information to pull items that have that and return it just like a listing call. And what's kind of cool, since we have multiple backends, you could actually be searching data that is on your local Zenko or on real AWS S3 or Azure, all with one searching mechanism. And it'll be all through a RESTful API call where you're just saying, I'm calling my Zenko as if it's S3. Give me a listing where it satisfies these certain attributes, and it returns back the listing. It'll be a query that you'll just say where whatever equals whatever, or any.
Just like a string, a text string query.
Yeah.
Okay.
Yep, thank you. So we'll have a demo. I just wanted to talk a little bit about how we looked at this. One of the issues there is with metadata search on an object store world is you don't know what your users are going to store. So if you look at a large company that has maybe 5 departments that want to use an object store, we're going to give them dedicated administration access. We're going to give them an IAM account, if you want to use these terms. And they will have their own users with their own groups and their own buckets. And there's no way of knowing in advance what they're going to store. So some people will store video files. It's going to be a small amount of larger object. Some people will store records with their own metadata. And so you need a solution that's very dynamic because you have no idea what kind of metadata will be available at a point in time. So user metadata is flexible. It's any key. And when you do a search, you actually do want to have some kind of typing because some attributes have different, it's more efficient to know what type they are. So for example, if it's a date, I want to be able to search and compare dates. I don't want to do a text match on January. I want to be able to say older than February, for example. So you want to be able to search into using date pattern, using integer, using float, using strings, using fuzzy match on strings. You don't know the format in advance. So it's a lot of things that you don't know. So we had to kind of find a way to solve that problem while making it easy for users to actually consume the system. So we look at a lot of different engines. We decided to use a Spark as our kind of engine to power the search. There's many reasons for that. One is it's very efficient on the large-scale analytics. It scales very well with a number of servers. It's easy to have jobs running and split the load into different machines. It can hold data in memory, which sometimes is good for performance. We can do some caching. We can be efficient. It has an SQL query interface. Amazon has released Athena, which supports SQL. It's a different type of search. It's search into the content of the object, not the metadata itself. But SQL is so easy to use and so well known that so many tools are compatible that we wanted something that can do SQL. Spark is very good at integrating with S3. There's S3 backends inside of Spark, so that it can store data via the S3 protocol, and that's useful for us in this situation. But what we're going to do is integrate Spark as part of our cluster and automatically deploy it as part of a Zenko deployment or a Scality Ring deployment. So this is what a query looks like. I think there was a question. So basically, that's the REST API view of things. I'm going to do a get on a bucket with a search and some attributes I want to search on. Though this is nice because it uses the S3. It's a REST protocol, so you can use the S3 API for authentication. So it's the same set of users and owners. It's not a different set of users and owners in a different database. If the authorization is OK, do the search and call Spark that will do the heavy lifting in the background. And so we're going to talk about that. There was a question of size of metadata. Do you recall our sizing guidelines?
Yes, 350 bytes per entry, roughly.
So it's not that big. It's actually compressed as well. So the metadata doesn't get too big. The user can put whatever he wants. So we could have users that put a very, very large metadata, but it's still nothing compared to the data itself. So I don't think there's a concern of capacity. So I talked about White Spark. One of the things that I didn't want to have in the design is another database, where you basically have two metadata databases that are not in sync by definition. So we looked at other designs. For example, using Elasticsearch. One of the concerns with that is that now you have these two metadata engines that have different information at a point in time that you need to reconciliate all the time. So we didn't want to do that. So with Spark, our metadata is the main engine, stays the main engine, and Spark is just there for processing on top, but we're not creating two databases. Speed, we did some benchmarking. We can get pretty decent speed where we need it, so less than a second for queries and scales well with the number of servers. It's very flexible, so we can do other things later on. For example, the Athena search in data can be done with Spark as well. And it's a big open source community. As I said, we want to do a lot of community involvement, and Spark is a good one. And there's a lot of ideas of things that can be done on top if we ship a Spark engine.
What am I missing about the requirement for scale here that you're using Spark? Is it that many queries coming inbound?
Yeah, so we got surprised. So some use cases are, I cannot really name it. So let's say you have a copy, like a PDF, and you have a million records per day, and each PDF has its own metadata, and you want to search into it at any point in time. So even if you only do 1,000 search per hour, that's still a big data set to go after. And the only way to get speed is to parallelize. So think of it as it's a Scality Ring deployment with 100 servers. You want to be able to parallelize the search so that it goes 100 times faster because you have 100 CPU resources.
Not just the number of search queries, it's the amount of data that you
can the amount of data that you have to look at.
I would think that would be more important for the analytics side as opposed to just a search. Is that what you're talking about?
No, so for example, you want to be able to locate your data on any arbitrary criteria, and that's really search, not just analytics. Analytics, it's a one-time thing. You know, you want to know all the objects that are bigger than that size. You do it once. This is more of some user comes and authenticate with its own for a passport, for example, which is different than an object name. I want to search by passport and by passport number.
So in theory, in most data stores, that would be really, really fast because you're just looking for a little bit of data and you're looking for one or two, right? So, okay, I'll listen some more.
Okay, thanks for the question. So now we can do a demo. For that, we need to switch laptops.
Okay, so I have, this is just a local Zenko running in that shell. And then I have a Docker that has Zeppelin running in it on top of Spark. Zeppelin's just a notebook for data analytics where you can run Spark queries. Makes it kind of easier for data scientists. It looks kind of, it's a light GUI. So to set up a search, a user would not have to do this. This would be what S3, what Zenko would be doing behind the scenes. But I'm just I'm importing my Hadoop configuration. I'm setting my endpoint to my local S3 that's running. I have my S3 access key, which is my default access key 1 and very secret 1. And then this is my actual metadata schema with my ugly Scala code. And so this is actually setting up the different types that make up the actual metadata. And I run that, nothing exciting happens, that's except for an error. No, it's fine. Okay, so that's just setting it up. My next step is I'm going to create this suitors data frame, it's actually called, where I'm reading in all of the suitors metadata from my suitors bucket. And here you can see, I'm just doing a show, so it's just showing all of them, so you can see all the suitors I have going on. And so then we actually want to do a query on them to find Romeo. So here, what these lines do is in Spark, you actually, for Spark SQL, you actually have to create a table out of your data frame, and that's what this does. And then here, you'll just see normal SQL queries. So I'm doing, show me my user metadata and key from suitors where the demeanor is moody. And then I'm just going to print that out. You can see I found Romeo here, and Hamlet actually also is quite moody. So picked him up as well. But if I wanted just Romeo, I could get more specific because it's full SQL. You can do ands, et cetera. So here I'm doing suitors where user metadata is demeanor is moody and monologues are long. There, I just have Romeo. To show that this can change as your data grows. And like the question is, why do you need something like this? Because your data can keep growing and then you'd have more and more metadata. I'm going to put some more suitors in my bucket. And then if I run this again, you'll see I have a longer list here. That was just updated by putting more data in my bucket. And then if I run the query, it'll run it on the new data frame. So now I have more results there. But luckily for me, my Romeo is just one.
Very cool. Nice job.
Any questions?
Do I have to do this kind of thing if I wanted to query a bucket? Because guess in my mind, I'm envisaging that when I want to go and find some objects, I want to be able to just do like a get query and pass it as a parameter.
Yeah, you won't be doing this. This is just to show conceptually how it's going to be working because it's a work in progress.
Right.
You would just be making a REST request like you're doing a get bucket with special query actions.
And it will go and figure out how to do this. Okay.
But then what are you pointing that GET request at? Because on a previous slide, you were talking directly to the Apache Spark. Wouldn't you be talking to Zenko to do that?
Yes. Talk to Zenko. Zenko talks to Spark.
Okay,
so you
that
don't
makes
have to talk
sense.
to
I
Spark.
misunderstood that, yeah. And obviously the benefit of that is you are then multi-object store. So part of your suitors, for example, could be on Amazon AWS and the rest of your something else could be on-prem or something. So the advantage of this, you've got a single query.
All of that, no matter where the data is.
What actually happens as the data is stored in the native format in AWS, for example, what happens if somebody adds, removes, deletes the data natively in AWS, then your metadata is going to be either out of date or messed up.
We frown upon that.
Okay. So again, you've got to have your access controls that, in a way, even though the data is stored natively, you'd want all your access via Zenko to keep it consistent.
Right. We view you should be looking at us as the true state of metadata for your objects on Real S3. If you want to be using the Zenko view, you can go directly to AWS to get objects, and they should look just like they look through Zenko. But deleting them and putting them on AWS S3 is going to mean you're going to get a different view than on Zenko because there's no way we know about them.
The unintended consequences of abstraction layers.
Yeah, no, exactly. That's a real, well, you've got to have your security set up properly to either avoid that, because you definitely in Amazon or Azure, you want to possibly be using the native cloud functions to do other kinds of things. So to access the data,
I think
but
the
not
way to
change
look
it.
at it is, first step, you will only read from the cloud. If this takes up and people actually use it, we're going to have to talk to cloud service providers and see if there's a way we can synchronize back. And that will make a lot of sense, but we're not there yet.
Yeah,
so, read only in the cloud.
Very good stuff. Thank you.
Thank you.
All right.
Nope. Well, not before the next one.
Okay, thank you, Lauren. So This is not intended to replace a database that you would already have, because you're going to keep your database if you want to do a lot of queries. This is for batch queries where you don't want to stand up another system to manage. So typically, when we talk to customers, they may have a Cassandra cluster just for metadata. And so that's two distributed systems to manage. If they don't do that many queries, let's have a query done by the storage so that I don't have two systems to manage, only one. But it's not replacing your traditional relational database. It's for batch jobs.